So if we're asked to use the law of sines here to solve the triangle, first we got to remember what it means to solve a triangle. To solve a triangle, that means you have to find all missing angle measures and all missing side measures. The way this problem's set up, you've got two angle measures given. So finding the missing angle measure for B here is not going to be too hard, right? Just take 20, add to 25, get 45, subtract from 180. Angle B is going to be 135. Now if you look at what else is missing, we are missing a side measure down here. Since that's opposite angle A, we'll call that little a. And we're missing a side measure up here. Since that's opposite angle B, we'll call that little b. How we're going to find these using the law of sines, let's just go in alphabetical order. Let's start with A. If I'm going to figure out what little a is, I need to take its opposite angle. Opposite little a is 20. Using the law of sines, I'm going to set up the sine of 20 degrees, and I'm going to place that over the side measure A. So you take the sine of the angle, you put it over its opposite side. Here, all we know as far as the a's are concerned, we only know the angle. So little a represents the side. What we need to set that equal to, we need to set that equal to something where we know all values involved. So it would make sense here to maybe work with the c's, right? Because we know what angle C is. We say the sine of 25 degrees, and we know its opposite side. See, it wouldn't make sense to set that equal to the sine of 135 over b, because we still have a variable in place over there. We don't know what b is. That's too many unknowns. So set it equal to a ratio where you know both values. Once you do this, we've used the law of sines to get to this point. Just do a little cross multiplication. We're going to take a times the sine of 25. Set that equal to, it'll be 80.4, that side measure, times the sine of 20 for the other diagonal. Trying to get a by itself, well, this sine of 25 is just a value. I'm going to divide that over to the other side. I divide that over, that gives me a. It'll be an approximation here because, well, we're going to have to use the calculators basically. Got to make sure the calculators are set on a degree setting also. But if we punch that into our calculator, the approximation we get if we round off to one decimal place, now let's see, I got 65.1. Whoops. So if I mark that off on the triangle, this equals 65.1. So if that makes any kind of sense, now as we go through and set up how to figure out B, we'll start with the angle that is opposite B. The angle that is opposite B is 135. I'm going to take the sine of 135. I'm going to put that over my measure of B. That's going to equal, I want to set it equal to a ratio where I know both measures. Now we have a couple of ratios like that, but I'm going to go ahead and stick with what we had with in the first place, the sine of 25 over 80.4. The reason I'm doing that is just in case I did make a mistake in finding little a here. At least I know the sine of 25 and 80.4 is accurate since that was given information. Solving for B, cross multiply just like we did for A. We'll have B times the sine of 25 degrees equals 80.4 times the sine of 135. We've got that sine of 25 again that's stuck to the B we're trying to solve for, so we'll divide that over to the other side. And B, since we got to do some calculating here, as an approximation, let's see, I calculated that out to be 134.5. Make sure you're calculating these as we go just to check. When you get done with these, take a look at how all the side measures match up. You got a pretty good idea that you're doing things correctly. You're calculating everything out right. When you start matching up the opposite sides and you see that the smallest angle measure that's represented matches up with its opposite side as the smallest side measure. And when you're taking the biggest angle measure here, matching it up to its opposite side, you got the biggest side measure. Pretty good indicator that you're doing things correctly. All right, now that we got the idea down for how we're solving using the law of sines, if we got to solve the entire triangle, what we'll do on this one, we'll kind of narrow down our search for what we're trying to find. For this one, let's just find what theta is. Because there are these occasional problems where you just need to know the angle measure, and we didn't have an angle measure on the last one that we could find without having to implement the law of sines. So let's try this one out. To try this one out, thinking about where theta is, well, theta is opposite 50, right? So if I'm looking for theta, I know that's an angle measure. That's the part I need to plug into sine. I need to set that up over the opposite side measure that I know. So I set up a ratio that's got the variable in it I'm looking for. Just as we did before, I'm going to set that equal to a ratio where I know all the values involved. It would make sense on this one that I compare the c's, right? I know angle C is 67. And I put that over its opposite side measure is 70. I set that up. Objective is to figure out what theta is. So cross multiply. If we cross multiply, got 70 times the sine of theta equal to 50 times the sine of 67 degrees. Solving for sine of theta at this point, you're going to divide 70 over. And this is one where if I'm solving for the angle, I'm trying to get rid of this trig function that's attached to it. So the only way I can do that is use the inverse of that trig function. In other words, theta here is going to equal the inverse sine of this big mess of a calculation over here, 50 times the sine of 67 degrees, all over, whoops, not 70 degrees, just 70. All right, we're going to calculate that out. This is how I would encourage you to try to punch this in. So we avoid any mistakes with all the grouping symbols, any parentheses we got to put in here. Let's go ahead and hammer out this guy right here. So if we plug that in, first let me make sure the mode's right on this one. It needs to be on degrees, which it is not. So I put that on degrees. All right, if I punch in this 50 sine of 67, go ahead and enter that in and then divide by the 70. Okay, that's the decimal that I need to plug into the inverse sign here. So I'm going to do second sine, and then I'm going to do second and the negative key, which brings down the answer. Hit enter, and there is my degree measure that I need for theta. Actually, it's approximation, so I round off to one decimal place, 41.1 degrees.